Hello all, thanks for joining my video. This time I will be talking about the Cineon inversion process for scan film negative, and I will talk the pros of using such method. The work with this very alternative and unique methods is because I wasn't satisfied with the currently available software for doing this kind of job. Don't get me wrong, the files that comes out of these softwares are beautiful in color, in tonality, but just like famous film scanners such as Fuji Frontiers, they will add their own character to the images, and in doing so, they are transforming the hues, the tonality, in a way that is not truly representative of what was in the film. So I wanted a method that really kept those characteristics and allow me to then in post do the editing that I found necessary myself. So let's first introduce what is the Cineon system. It was developed by Kodak during the 90s because the industry was in a period of transition from the film negative to the digital medias, and they found out that they needed a way to reliably transport all the data that was within the analog formats such as film negatives to a digital file. So their biggest challenge was that film negative contains an incredible dynamic range of information between the darkest shadow to the brightest highlights. And to make sure that all that information weren't getting lost in the translation to the digital file was the main focus of such system. So it needed to capture all the information on the negatives so that it was future-proof and easy to work with. So specialized hardware equipment for doing such a scanning process were developed by the companies such as Arri. They are one of the biggest companies in the film industry for cameras and other specialized equipment. And just as curiosity, here I'm showing their page of their latest dedicated scanning equipment, and scrolling down the page to see the features, we can see similarities to specialized photography scanners that we have had access for decades now. This illumination process of the film negatives, the same as those used in Fuji Frontiers with RGB LEDs. And when we check the outputs standards, we can see it outputs Kodak Cineon standard, among other options. So this is the industry standards of the motion pictures to this day when a film is shot on negative or positive film. So how do we work with such a method? This is where Davinci Resolve really shines. It is the only software that I have found out so far that allows you to work end-to-end on your files, keeping the native RGB sensor information untouched, meaning there is no color transformation of any kind unless there's a direct command to do so. And keeping this native RGB data from your camera sensor or dedicated scanner will deeply impact in a positive way the quality of your film inversion. So I believe this is the most complicated aspect of this process. And to explain why we have to do this step, it's because Davinci Resolve is a software made for the video industry, and while it allows the processing of certain raw formats, we don't have full control over this process on how it's made internally. So LibRaw is a software library that transforms the data within a raw file into a much more compatible format. Doing so gives us full control over this process. You can go to the page that I will be showing on the video description to download either the macOS or Windows version of LibRaw. In this case, since I'm working on a MacBook machine, I will be showing my process for macOS, including a much simpler way for the installation and usage of such library. So to start, we will be installing a package manager for macOS, which will make the installation of softwares much easier within terminal. So this is Homebrew. It's the one I use and recommend. You go to the website and there's a line of code that all you have to do is to copy that line of code and paste on your terminal. So if it's your first time using terminal, find it on your system and let's open it. Now that it's open, this is where we will be pasting that line of code that is the Homebrew's web page. So I click there to copy that line of code, and all I have to do is to paste it here in the terminal and press enter. I won't be doing that because I already have the Homebrew installed, so you want to actually do anything, but that would start to download and install a lot of specialized software. You don't have to worry about it. It will tell you when it's complete. So after that step's done, you have Homebrew installed on your system. Now the installation process of a software that is within Homebrew is simple. You just have to type brew space install space the name of your software, in this case LibRaw. I do just that. I'm doing here as demonstration since I already had it installed. So it's telling me that. And now you have LibRaw ready to be called for in terminal, and you can use it for the process we are going to go over to extract the data from the raw file of your scanned film negative. So first of all, let me explain what is the line of code we will be using for the raw file, what it does to the file. Of course, you can go and read the manual of LibRaw to understand more, but I like to make it clear so that each step is clearly understood. So here I have the files from my Nikon camera that we will be using for this demonstration. So you have the folder open with those files. Let me call the command cd and the folder path so that the terminal goes to that folder. And here I'm just showing I am actually in that folder. Here are the files, the same files that's showing on Finder. And here I am calling the command we will be using for this process. So it looks complex, but it really is not. So I have written the explanations of each of those commands. DCRaw emu is the emulator for the DCRaw. This is what LibRaw is doing. It's calling DCRaw, which is used by most photo editing softwares. And the -v is for verbals, just for description of what is happening. And -q3 is the quality of the demosaicing algorithm. We are using 3, which is the highest quality one. -w disables the automatic brightness of the file. -4 writes a 16-bit linear output, which we need. -0 outputs the native color space of the file. This is very important because it won't touch the color. It won't do any transformation with the color space. And we want that to work with a film negative scan. -T outputs a Tiff file to use within Davinci. And -C0 and -H1 is about the highlight and clipping methods that work best according to my own experimentations. So after this command is written, is typed, we just grab and bring to the terminal the file we want to do the process, type enter, and we have the .tiff file already on the folder. So it has done what we asked for, and here's the linear TIFF 16-bit file that we asked for, and this is ready to be imported into Davinci for the inversion process. So let's do the same for all other files. You just select them all and drag to the terminal. Looks crowded, but don't worry, just press enter and it will do its job. So it's doing it now. We are getting the TIFF files from all your scan negative. It's not very long to do so. And here are our files converted by LibRaw. So now we are going to the next step, which is install the GCLT that actually does the film inversion process according to the Cineon method. We will be using Thatcher Freeman free utilities for Davinci. It's really incredible how much quality there is in this package, given it's free, and there's so much that can be done using this. And the one that we are looking for is called Process Film Negative, DCTL. DCTL is like a script for Davinci Resolve. So here in their page, we have a small description of what it does, and there's a parameter of each item so that you can study the functionality for each, how it works, and better control the process. But it's very simple. So to install this, we are going to open Davinci Resolve. And I think I forgot to say, we need the Studio Davinci Resolve to do this. Unfortunately, only the paid Davinci license allows us to use DCTLs. You can't use the freeware Davinci. So go to File and Project Settings. And within that menu, we're going to Color Management and scroll down that page to find the Open LUT folder. This is where the LUTs and DCTLs for Davinci are read from. So we want to bring the downloaded DCTLs into this folder so that Davinci can properly load them. So to download the utility, you click in Code, the green button, and download zip, so that it downloads everything that is available. Once it's downloaded, you are going to open that zip file and bring all the content of the zip file into this LUT folder. I have done so already, so I won't be doing so again. And here's the utilities folder with the DCTLs that we just downloaded. Now you restart Davinci Resolve so that next time it opens, it is able to correctly read and load the CTLs. So we can finally start the process of inverting the film negatives within Davinci. Now, first of all, before we bring the file into Davinci, we want to make sure our project settings match the description and especially the resolution of the file we will be using as scanned by our camera or scanner. So within Davinci, you go to File, Project Settings, and in the first page, you have to adjust timeline resolution so that it matches the resolution of your scanned file. So let's see here, what is the resolution? Okay, this is the resolution. My camera captured this file, so I'm going to match that data here within Davinci. And before we close, go to color management and make sure the color science option is Davinci YRGB and not YRGB color management. We don't want to have a color management process by Davinci. The rest leave untouched. Now we are finally ready to bring our file into Davinci. So drag your Tiff file into Davinci, to the media pool, and then drag it within Davinci into the timeline, to the start of the timeline. So here we have the file loaded, showing properly on the right screen. So opening the inspector tab, you can adjust the position, rotation, flip the image. This is the main place to do so within Davinci. I have corrected the image so it fits correctly. And now we go to the color tab on the bottom side of Davinci. This is where the inversion process will happen. Now, Davinci works in a node-based. If you don't know what that is, I recommend you go through some tutorials on YouTube. It's not very complex to understand, but it's very important to understand how to work within Davinci. So first of all, open the Effects tab and drag the DCTL effect as a new node. It is applied, but we haven't selected any DCTL. And now you go to DCTL and find the DCTL we are looking for, which is called Process Negative Scans. If you have done the installation process correctly, it should appear here. Now, as it loads, it has already done the inversion process of our negative. However, it has a very strong blue cast. That happens because it needs a sample of our base of our film in order to properly reference how the inversion process should happen. So next step is to pick the color base area using the picker besides sample dimming. But before we do that, let's add another serial node so that I can show you a trick I do for this process. So add another serial node and you're going to go to effects for that and add a Gaussian blur effect on that node. What we're looking to do is to smooth that area so that when we use our color picker, it's capturing an average of the region and not the individual pixel. So adjust the blur value until you feel it's smooth enough and then pick the sample base area. And now you can delete the blur node because the job has been done. So now the negative looks very dark, and that is because output mode is set to linear. We need to correct that. So here's the Cineon output mode. This is the unprocessed conversion, and now the gamma output mode is where it's processed for our monitors using proper gamma curves, and it's much more pleasing to the eye. So the first thing we can do to this image is to white balance it, so we get a better representation of the scene. I'm going to a region where I believe I have neutral gray, these rocky areas, so I can use the picker of white balance, and now it looks much better to me, to how I remember the scene. And this is a base conversion without any dedicated adjustment yet. So here we can adjust the print global, which is basically exposure control of the process. Print gamma is like a contrast, fast contrast adjustment. It only works in gamma output mode. Display gamma is to adjust the display output of the file if you want it to 2.2, 2.4 gamma. And you can also flip the image here directly instead of the inspector page of Davinci Resolve. So as you can see, it streamlines the process very much. It's very easy to work within this CTL. So how to export the image after we're done? Go to File, Export, and Current Frame as Still. Then you pick a Tiff extension that it keeps the 16-bit maximum quality. Pick a folder where you want the file to be outputted. Name it. I'm going to name it Export Cineon and Export. And now if you go to that folder, you should see that the file has been exported as a TIFF, and here's the end result with the same resolution as our original scan negative, and you can edit it later however you want. Now, for the last process, let me show you how to do this in a batch fashion, so that you have a whole row of film scans to process. So let's do this in a much faster way, so that it is consistent within the same row. You can fastly adjust, export it, and this is how I process all my film negatives. So you have dragged them all into Davinci, add it to the timeline, go to the color page, and click clips. That is going to show you each individual file that has been imported to Davinci. So here I have a photo of a color checker, which is very convenient because we can use it to white balance and adjust our settings. So do the same process as we did before. Let's add a node to use Gaussian blur to make the base selection more even. Let me adjust it here. So now let's pick a sample of the base. Okay. Delete the Gaussian blur node. Move the output mode to gamma. And this is where this batch process is really helpful. So we have a perfect image to pick a white balance. And we want to apply that same white balance to our entire row, because this is the most accurate white balance representation we're going to have. So how we do that in Davinci? You right click on top of the image and click grab still. What it's doing is not capturing just a screenshot. It's capturing everything that's happening to get that image output. So that's still showing on gallery. And now all you have to do is select all the clips and middle click the mouse wheel over no mouse, and it will apply that still to every clip you have showing. So we have that same base and same white balance applied to all the frames. So you only have to do the process once. So this makes your images much more consistent in look. And individually you can check each one and readjust the white balance if needed. Here, these photos were taken during sunset, so the white balance was shifting rapidly and it's showing as I move to the other frames. And you can adjust the exposure, the gamma, the contrast, and also the white balance manually using printer and RGB. And after we're done, let's go through a process to exporting all these images in a fast and convenient method. So go to the deliver page within Davinci. It's the last page on the bottom. So let's pick the location where we want those files to be exported. So I'm selecting the folder. Let me create a new folder called output and select it. In render, select the individual clips option and format, choose TIFF. Codec, let's pick RGB 16 bits for maximum quality. And this is very important, pick the render at source resolution. This will make sure that the resolution of the file will always match the input. Add to render queue and render all. Now I'm doing something wrong here, so it won't actually work this first time because I forgot to set the file name of the files so that it keeps the original file, so it's overriding each time it's outputting a new file. So I go back and I have to make sure that file name is selected as source name. When you click add to render queue, it should say source name like that, so it will keep the original file name so it doesn't overwrite when it goes to the next file. So I redo the process and I have all the output files showing on the folder I picked. So I'm going to open, and here you can see we have successfully converted all the frames on the scanned row of film negative in a very short time. So I hope you liked this demonstration, and please let me know how you find your results. This won't output ready conversions, but you can trust it's exactly what was on the negative, and it's the best base so that you can work over it and add it to your liking. So thank you very much and happy shooting.